Hello everyone. Today I'm going to give you a basic intro into classes in Python. So I'm going to create a project here called Python classes. Okay, I'm going to clean it up a bit. Creating classes is a very good way to organize code. It allows you to associate a bunch of methods and properties to a certain type or whatever that class may be. So for example, you could make a class called dog and you could give it a bunch of methods like bark and shake, and you can have those methods do certain things, but it's associated all with a dog class. And that way you can have all the code associated with a certain kind of type of thing in one place. And a lot of times you want to use classes in your code to represent a certain idea or type of object. And what you can do is then create instances of that object and use them in your code. So let's start by creating a class, and we're going to create a class called animal. So in order to make a class in Python, you have to use the keyword class, followed by the name of the class that you want. We're going to create class animal, and Python has some built-in functions that you can use that do specific work depending upon what the name of that function is. So one of these functions is underscore underscore init underscore underscore. It stands for initialize essentially. So Python recognizes these types of functions in classes automatically. So it looks like this. And you can see PyCharm's already suggesting the function because it recognizes it. So what you do is you pass in self and you pass in any other arguments after self that you want to use when creating your object. I'll give you an example of how to add more arguments to the initialize function, but for now let's just use self, which is required when you want to be able to call or create this initialize method in a class. So what self is actually a reference to the object that's being created. It's really important to understand the difference between a class and an instance of a class. So you can think of a class as like a definition for something, and you can think of an instance of a class as an object that meets the required definition of that class. So if a class has a bunch of methods or properties, then an instance of that class will be a specific object that also has those properties and functions, but you'll be able to use those on the object. It's like, let's go back to the dog example. If you have a dog class and you define a bunch of methods in it, well, that's just a definition for the class. But if we want to use it, we have to create an object of the dog, and that object is the one that can actually do the barking or whatever other methods you put in there. So self is a reference to the instance of the class in question, not the class itself. And there'll be more on that later. Often what happens inside these initialization functions is any kind of work that needs to happen, and also initializing variables for that object. These variables are often called instance variables. So each object will have its own set of these variables associated with itself, and these variables don't get passed around between each object. In the animal class, we're going to give it only one instance variable. In order to do that, you need to have a reference to the instance itself, which is in this case self, and then we want to, after that, define the name of the variable that we're going to use. So in this case, we're going to write animal type, and that's going to store the type of animal that this is. In this case, because animal is generic, we're just going to say animal, but it'll be useful in the future. So far, if we created let's make a thing down here. So we're going to create an instance of this animal. We're going to say animal1 is equal to animal. And that is how we create an instance of an animal, an object. So animal1 here is a reference to an object. And the class of that object is animal. So it's an object of type animal, but it itself is an instance, and it's not the same thing as a class. So you wouldn't say animal1 is the class animal, but the type of animal1 is animal, if that makes sense. So again, the class animal is a definition, in a sense, of a certain type of object, and animal1 in this case is an instance that meets that definition. It gets created based on that definition. So here, because we have self.animalType equals animal, that means that animal1 will now have this instance variable associated with it, and we can actually grab that value out. So we can get the animal type from animal1 now, because we gave it when it was initialized. And so what happens is once you call animal with these two parentheses, then it's initializing a object animal, and this init function automatically gets called, and then the self.animalType gets assigned, so it gives the animal object an instance variable called animalType and assigns it to animal. So now animal1 will have this value. And you can see it worked. It printed out animal. And just to make this clear, if we made another animal2, we can also get the type out of that. And it will be the same thing because they're both using the same definition. It's automatically getting assigned to animal. I want to show you though that these objects are not the same thing. And we can do that by making a simple comparison. So what we can do is check if animal1 is equal to animal2. And you'll see that it's not true. So it's false. Animal1 is not equal to animal2. That's because even though animal1 is a type animal, and animal2 is also type animal, and not only that, but they both have an animal type assigned to animal, they're different objects. They're totally different animals. Just imagine you see two dogs out in the street. Well, they're not the same thing because they're both dogs. They're both a dog. That's true. They have that in common, but they're not the same dog just because they're both dogs. Same thing works here. You have animal1, animal2. They're both animals, but they're not the same animal. Let's remove this and continue on. We're gonna create some methods for our animal class. Some more methods. The first method I want to make is a method called getInfo. So we're gonna call it getInfo. And again, we have to pass in self if we want it to be a instance method. So if we want to be able to call it on an object. And what this is going to do is, actually, I want to change this to say print info. That way we don't have, get info implies you're going to return a string, but I don't want to return anything here. I just want to print out some information. So what this is going to do is print out information about the current animal. So what we're going to do here is we're going to say this object represents an animal of type, and then we're going to pass in the animal type. So literally all it's going to do is when you call print info on the object, it's going to say this object represents an animal of type, and then grab the instance variable animal type of the current object. So in this case, it's going to be animal. So let's call this method and test it out. What happens when we call print info, by the way, is in a sense, animal1 automatically passes itself into print info. So it's almost as if this comes through like that, and then self becomes animal1 like this. But it's kind of behind the scenes, so you don't really need to do that. Animal1 automatically gets passed into bself. Python does this under the hood. So when we run this, you'll see this object represents an animal of type animal. So we're able to call this method that we made on the animal object. So now the animal class has added more to its definition. It has an initialization method, and now it has our custom print info method. And the final method I want to make is going to be make sound, and we're going to say print this animal does not make any sound, because we don't know what kind of animal it is. We just know it's an animal, so we can't really say what sound. So for the sake of this, I'm just going to say this doesn't make any sound. And we'll see that. This animal does not make any sound. Great. So we have an animal. We print out its info. We know that it's a type of animal. We try to make it sound, but it can't make a sound because we don't know what type of animal it is, so that's all we have for now. So now we're going to make a new class and call it pet. And we're going to, I first want to show you something. So we're not going to have anything inside the body of class. It'll have nothing. But I want to show you something called inheritance. So the pet class is going to be a subclass of animal. So one way to think about it is pet is going to be a child class of animal, and animal is going to be a parent class of pet. In order to do that, all we have to do is add some parentheses and pass an animal. And now what kind of happens is, in a way you can think of it as all this definition stuff getting automatically pasted into here. That's kind of what happens. That's way too much of an oversimplification, but that's kind of a way that you can think of what's going on. Is now the pet class will inherit the definitions that we've given to animal. So what we can do down here is literally just replace animal with pet. And it still runs and it works fine because pet also has the same definitions as animal, because pet is a child class of animal. So now we can do an interesting thing, and we can check to see if animal 1 is an instance of the animal class. And it is, even though we created a pet object, because pet is a child class of animal, it's both an instance of animal and pet at the same time. And I'll show you just to be sure that it is an instance of both animal and pet. So yes, animal 1 is both an animal and a pet. If we switch this back to animal, however, we're going to see that it's not a pet anymore, because when you create an object of some class, it is a instance of its own class and any parent classes, but it doesn't apply the other direction. You can't just create an animal class in this case and then say, oh, it's also an instance of pet. Well, it's not. We created an animal, and animal up here, it never knows about pet at all. It's created as its own class, and it has nothing to do with pet at this point. But pet is associating itself in a sense with animal. It's becoming a child class of animal. So let's remove this. And now we're going to do some more stuff with the pet class, not just an empty body. So first I want to show you how we could call the initialization of its parent class, which is animal. So if we do super.init, what super is really doing is it's calling the parent class of pet in this case, which is animal. So this is calling the initialization method of animal. So it's literally calling this method. You can see that this will still, I'm going to change this to pet again. And this should all work the same. It does. I'm going to remove this. And then I want to call print info. So now when a pet initializes, it will call the animal's initialization method, and then it's automatically going to call the print info method. So that's fine. But I want to show you another thing now. I want to change the animal type inside of here to be pet. And then I want to call print info again. And I want to show you that print info will depend on animal type. Even though print info is defined in here, it still relies on this instance variable, and this instance variable can change at any time. So when we go through this step by step, we call the initialization of the animal class, which sets the instance variable animal type to animal. So after this is called, then self.animal type is going to be animal. And then when we call print info, it's going to grab the animal type and see it's animal and put animal here. But then we're going to change the animal type to pet and then call print info again, and now it's going to be pet here. So it switched. And that's totally okay, but this is not what we're going to do here. What I want to do here is actually just remove both of these and make the animal type just pet. But we're going to make it lowercase because I like consistency, and animal is lowercase. So. And the other thing is we don't need this initialization on the superclass anymore because we don't want this work to happen. It's not necessary anymore because we're setting it here. And if we run it, well, I'm not calling the method right now. Let's do it. If we print info now, it'll just say pet. One final thing is if we didn't do this and then try to run it, well, first we need to put nothing in here. So let's put nothing in the initialization method, and then let's run it. Well, there's an error because we never actually created the animal type instance variable anymore, because we're not calling this anymore because we removed it, and we never set it in here. So when we call print info down here, print info is going to try to find self.animal type, but animal type's not defined anywhere. We never defined it in the initialization of pet, and we didn't call the parent constructor up here, the initializer. So let's move this back, and let's add some more methods to pet. So we're going to do an introduce method. And this introduce method is going to print out some things. Rather, one thing. It's going to say, hello, my name is, and then self.name, which doesn't exist yet, and let's format it. So now we want to create a name for pet. So right now self.name is nothing, but we're going to give pet a default name. Let's make that default name no name. And now let's test this out. Animal1 dot introduce. So now when we call introduce on the pet, it's going to say, hello, my name is no name, because we gave it a name of no name. So now that we're done with the pet class, I want to make another class. And this class is going to be a dog class, and that's going to inherit from pet. So now let's think about what's happening. So we have our class animal definition up here, and because pet is a child class of animal, it pretty much gets all these, well, I guess both of these functions passed on to itself. And so now pet has its own initialization method, it has its own method introduce, but it also gets print info and make sound from animal. But now we have a class dog, and that's a subclass of pet. So what this class gets is everything that pet has, and pet is getting everything that animal has. So dog has all the methods that pet has, and pet has all the methods that animal has. So dog will have print info, make sound, and introduce. Let's give dog a initialization method. So now what we want to do is actually give it a different animal type. And now we can actually use animal types that make sense. We're going to say dog. It makes sense that an animal type of dog is dog. But we also want to give it a name. But what name do we give it? We don't want to assume what the dog's name might be. We want to be able to have whoever uses our dog class to give it a name. So now we're going to actually add an argument to the initialization method. And so we're going to say name. And now we're going to assign the instance variable name to whatever name gets passed into here. So now we're going to change pet to dog. And we're going to see that, well, first of all, PyCharm is giving us a warning that we're not filling in a name. So let's give it a name. Let's call him Bones. Sure. And let's run this and see what happens. So now, because we've given the dog a name, Bones, when we call introduce, it's going to use the name that we just gave it. So it's going to say, hello, my name is Bones. The other thing is that when we call print info, because we've changed the animal type to dog, it's going to use the animal type of dog when we print the info. So it's going to say, this object represents an animal of type dog. Now I want to show you how to override a method. We're going to override the make sound method that is created in the animal class. So we're going to pretty much hide this and give it something else. We want to print out bark, because that is the sound a dog makes. So now when we call bark, or sorry, now when we call make sound, instead of saying this animal does not make any sound, it's going to actually bark now. And it worked, because we overrode what happened here. Just for informational purposes, I want to show you how we could call this make sound. We could override it, but also call the original make sound. We would have to do some extra work. So we would have to call super.makeSound. And what that's going to do is call the parent class, pet. That class is makeSound, which is the makeSound of animal because it doesn't override it itself. So now it should do both. It's going to call, when it calls makeSound, it's going to call the super classes makeSound, which is pets makeSound, which is animals makeSound. So this animal does not make any sound, but then we also print bark after it. So it's going to bark as well. But this doesn't make sense, so let's remove this. That was just for informational purposes. I want to show you one more class, and we're going to call it Zebra. And this class is going to be a child class of animal. And we're going to give it an initialization method. We're going to give it an animal type of Zebra. And because it doesn't actually, it's not a child class of pet, then giving it a name doesn't really make sense because it's not going to have this introduce method because it's only a child class of animal. So it only gets these methods and it doesn't get introduce or anything. So giving it a name will not do anything. And then we'll override the makeSound, and I actually don't know what sound the zebra makes. It's probably like a horse, so let's just do neigh. And let's change this to zebra. And we have to comment this out because introduce does not exist anymore. Because introduce is only a definition, it is only a method that exists for pet objects. And a zebra is not a pet object, it's a zebra object which stems from an animal object. We also cannot give it a name because a name is only given to pet objects, but it has its own constructor which doesn't take any other parameters. It only takes itself, so we actually cannot give it a name like I said. I just forgot to remove this, so let's remove bones and run it. Great. So now I want to just give you a summation of what happened here. We have a class animal, and that has a child class pet and a child class zebra. So my thinking was zebras are not really pets, so it's only going to be a child class of animal. But because a dog is a pet, it's actually going to be a child class of pet. And now you can see in a way how you can organize your code to kind of compartmentalize different attributes and properties into a certain type of object. And what this does is it makes it more readable. It makes it easier to pass these objects around instead of a bunch of properties and whatnot. We can just have everything inside one object, and that object can have its own instance variables and methods that can perform certain actions. So I want to show you some more instance stuff. So let's create a dog, and then let's print out, oh, we have to give it a name. Let's give it bones again. And let's say print is instance, and then is dog an instance of dog. Run it. True. Is dog an instance of pet? True, because it's dog is a subclass of pet, or a child class. And then is dog an instance of animal? Yes, because dog is a subclass of pet, which is a subclass of animal. But now let's take a look at the zebra object that we made above, which is animal 1. And you'll see that, yes, it is an instance of animal, true, but it is not an instance of pet because zebra is a child class of animal, not pet. There is one final thing I would like to say about the code that I have here in front of you, and that is that I don't actually call the init anywhere for any of these classes, and I can do that, and I'll show you. Let's call init for every single one of them, and this really won't make a difference in the code that we run, but it's normally good practice because if you, in this case, we don't have any dependencies on what happens inside the parent classes because, for example, we have the animal class with an animal type. Well, for all of its subclasses, we give it an animal type inside of it, so we don't need to call init. But I showed you earlier when I removed, for example, animal type, it had some kind of error, and that's because we never gave it an animal type, and then we tried to call print info, and print info needs the animal type to be there. So I'll show you again. And now you see that it's working because we are calling in it. But if we didn't call in it, it would throw an error because animal type doesn't exist. It's not, we never assigned it. So that's why it's generally good practice to call super.init. And in this case for zebra, if we call super.init, it'll go up to here and then call the init that animal has. And the animal type will be set to animal, and then that'll come back and finish. But then animal type will be replaced with zebra, so it really doesn't do anything. It won't cause any harm to call the init. In fact, it's just good practice in case you make more changes down the line. But I left it out because none of the classes rely really on the parent's initialization method itself, because it does it all, everything it needs in their own respective initialization methods. And I put a super initialization in here. That's not necessary. And I want to add that anytime you create a class that doesn't have any parentheses with another class inside of that, meaning like if I don't give it a parent class, it automatically derives from the object class in Python, which is like the parent of all classes. So that automatically happens. But yeah, there's no reason to really call super init on the animal class because we don't need to rely on on Python's object classes initialization. It doesn't really do anything. But again, it is good practice to leave in the initialization calls to the super classes because it shouldn't have any negative effects. If anything, it'll help you not make any mistakes when you add more code. All in all, I hope this gives you a basic introduction to classes in Python. This is already complicated, and it does get more complicated. I may end up making a video explaining how to do more advanced things, such as having multiple inheritance. So for example, a class can inherit from two different parent classes. So zebra, for example, could inherit both animal and pet. But that gets very complicated very fast. So at a base level, this is what I want to show you today. But in general, you won't probably have to use multiple inheritance, and it gets more complicated. So for now, this is going to give you a lot of room to grow and practice. If you have any questions, please ask down below. Or if you want to see more videos like this, please subscribe. And thank you for watching.